everyone, and welcome to our Year 9 chemistry session on a Sunday morning run by Elite Medics. So my name is Deborah, I'm a fourth year medical student, and I'll be taking you through our content today. If you haven't joined an Elite Medics session before, welcome, and if you have, welcome back. So the way that this is going to go, I'm going to give you an outline of the day, timings, when to expect what, and then what you should expect from us, what we expect from you, etc. And then we'll go into what we will be learning today. Very interesting topic, actually. So here first is the outline of the day. So from 10 to 12:30 is going to be our learning time. Don't worry, there will be breaks in the middle of this because I don't expect you to focus for 2.5 hours straight, okay? And then from 12:30 to 1:15, we have our lunchtime. And I'll let you know when our lunchtime will start and end. And then finally, we come back for our last 45-minute session, and we aim to end at 2 p.m. today, okay? So these are the rough timings for today. Don't get bogged down by memorizing them. I'll tell you guys when we will have our breaks, etc. And next, we're going to be talking about what to expect from us. So we at Elite Medics, if you guys haven't been here before, we think that interaction is key, and we really like to get involved with you guys to see if you are really understanding the content that we're going over today. So we'll have a few Slido interactions in our session today that you will be able to log on to and have access for the rest of our time today. All right. And of course, with any kind of content that we will be revising, learning today, etc., there will be questions. So please put that in our Slido Q&A section, and we will aim to answer as many as we can, all right? It's likely that we won't be able to answer every single question, but if there is a question there that you see and you really want the answer to, make sure to upvote it, because it's more likely that I will be able to answer that question, okay? So, for those that have just joined us, once again, my name is Deborah. I'm a fourth year medical student, and I'll be taking you through Year 9 chemistry today. And specifically, I will be taking you through organic chemistry. Yes, I remember back when I was at GCSE, this wasn't actually a topic that we covered until A levels. So it's going to be an interesting time for you guys, but I know that you guys can do this, because organic chemistry, once you actually get the hang and the swing of things, exam questions can be relatively repetitive, and to the point where once you understand it, I must say I did sometimes find organic chemistry quite fun because it had this set pattern, and every time you went in, you're just doing similar kinds of things, all right? So in particular with organic chemistry, we are going to be covering alcohols, carboxylic acids, alkenes and polymerization. That's really important. And then finally, we're going to end it off with amino acids, okay? All things organic, as you guys can probably see. So for you guys to be able to sign on to Slido, here is our first interaction. If you have been here before, you know the drill. Please scan our QR code on the left-hand side of your screen, or go onto slido.com and type in our login details just underneath, okay? So all I want you guys to do is to rate how confident you feel with these topics. 1 being, I've literally never heard of this in my life. 5 being, I've heard about this quite a bit. I could answer a few exam questions and, get them right, etc. Okay, so I'll give you guys a couple of minutes to do that so everyone has a chance to sign on. And of course, guys, with everything that we're going to be going through today, it will be handed to you, the slides, the recordings, etc. Okay, so don't get too bogged down by taking beautiful, beautiful, beautiful notes, okay? Okay, I'll put this on for a couple of more minutes, but currently seeing from how we're rating our confidence in this, it's clear that organic chemistry is still a rough subject for a lot of people. Because traditionally, people did find organic chemistry quite a bit to get your head around. So don't get too bogged down if you don't understand it immediately. It's a good thing you're here so that we can take you through it, and hopefully you'll be able to understand and actually realize that organic chemistry isn't as daunting or as difficult as you might think, okay? All right. So I also used this slide just to see how many of you guys have roughly joined us today. In the meantime, though, if you guys want to get yourselves a pen and paper, if you don't have it already, because there might be some times where we'll be actually drawing out some of these structures. So I don't want you guys to be coming back, and then missing the content, etc. Okay? All right, I put it up for 30 more seconds, and then we'll get into it. All right, folks. Also, don't worry if you just logged on and for some reason Slido is just not agreeing with you at the moment, you can't log on. Every time we have a Slido interaction, our login details will always be on the left-hand side of our screen. So you will be able to log on at any point and have access to the questions that we go through the rest of the session. All right. So thank you guys for voting on that. In particular, this is what we're going to be going through today. Okay. So we're first going to understand the importance of the functional group. Okay. There are a couple of terms that you guys might see associated with organic chemistry. Don't get too bogged down by them, because when you actually understand these keywords, it's actually very simple and straightforward. Okay. Moving on, we're going to be understanding and recalling the structures of the first 4 alcohols, as well as understanding reactions of all alcohols. We're going to be doing the same for carboxylic acids, understanding their structures and their reactions. Then we're going to be understanding addition polymerization and condensation polymerization, okay? And then finally ending off with recalling the general structure of amino acids and understanding the formation of polypeptides. Nice. So we are going to launch straight into it. We have a very random quiz question to start us off to keep us on our toes. So please type in the username you want to be referred to in our leaderboard. And I will flash up this quiz question. I'll give you guys a minute to do so. All right. I'll take this opportunity to personally say hello to some of you folks. So hello to Annabelle, Ria, Jaden, Shreya, Manya, Isa, Aditi, Natalie, Mikhail, Fiona, Jazzy, Mira S, Dylan, ooh, Tiger Boy, Freya, Ash, Jeff, Megs, Alex, Lol, Catty Jane, Human, Ashma, Big Ed, Camilla, all of you folks. I'm probably not going to be able to say hello to everyone because all of these usernames are coming in so quickly. But for those that I've missed off, I'm so sorry. But hello and welcome to our quiz. All right. So if you guys have never joined us at Elite Medics before, I'm going to explain how these quizzes work. All right. This will be our running total throughout our whole session. We have a couple quiz questions interspersed between the content we're learning today. To get points, you have to primarily, number 1, answer a question correctly. All right. That is what I want you guys to prioritize, answering the question correctly. Number 2, You move up the leaderboard by answering quickly as well. Okay, so please keep these two things in mind. Fingers on buzzers, guys. The question is coming up in 3, 2, 1. Titan is warmer than the other moons of Saturn because of the greenhouse effect. How do greenhouse gases trap energy from the sun? Is it all wavelengths of radiation are reflected back to the surface of Titan? Is it long wavelength radiation is reflected back to the surface of Titan? Or is it that short wavelength radiation is reflected back to the surface of Titan? What do we think, guys? How do greenhouse gases trap energy from the sun? Right, 30 more seconds, guys. Is it all wavelengths of radiation, long wavelength radiation, or short wavelength radiation? 15 more seconds. 5, 4, 3, 2, 1, 0. Let's see what you guys have said. Ooh, a bit of a split. So the majority of us, though, voted for long wavelength radiation. Are you correct? You are. Well done. Okay, it's 48% of you that got that correct. All right. So remember, guys, when we are talking about the greenhouse effect, just as an aside, this is essentially the Earth trying to trap energy from the sun so that it can regulate its own temperature. And we do this by the gases in our atmosphere. If we didn't have those gases in our atmosphere, Earth would be a very, very cold place, okay? Not sustainable to life. So the way that that happens is that our greenhouse gases in our atmosphere are trapping long wavelength radiation. You guys have probably also heard it referred to as infrared radiation. Okay, so that's on the electromagnetic spectrum, if you guys have heard of that before. Okay, this electromagnetic spectrum is essentially just a spectrum of different wavelengths of radiation that have different uses and purposes in everyday life. Okay, this one that we are talking about in particular is our infrared radiation, which comes in the form of heat. And these greenhouse gases trap this infrared radiation so that it is reflected back to the surface of, in our example here, Titan, and this helps regulate its temperature, okay? Which means that Titan is warmer than other moons of Saturn, but still probably not as warm to sustain life there. Anyway, well done, folks, for our first quiz question. There are so many more to come, and here is our leaderboard. People are answering in record time. Blobfish, my goodness, 5 seconds. Well done. Followed by Creation Myth. AA Ray is biggest brain. Interesting. KK and chocolate. And well done to all of you guys that got that correct. Don't worry, guys. This leaderboard can literally change every section. Anyway, so let us start now with organic chemistry, because this is a daunting topic for a lot of us, okay? So let's first take a step back and figure out what actually is organic chemistry. Is it the study of single cellular and multicellular organisms, the study of organic matter, the study of the structure, properties, composition, reactions, and preparation of carbon-containing compounds, or the study of organic foods and their benefits? I think this is really important to have clear in our heads, because then when we think about organic chemistry, we know exactly what to expect. Okay, I'll give you guys 30 more seconds on this, and then we will move on. What do we think organic chemistry is? All right, 5, 4, 3, 2, 1, 0. Lovely. Yes. So organic chemistry is essentially the study of the structure, which is what especially we're going to be going through with some of them today, their properties, composition, reactions, and the preparation of carbon-containing compounds. All right. So the emphasis here is that we're going to be focusing on carbon-containing compounds. All right. Now, thank you guys so much for voting on that. We're going to delve a bit more into this. So in organic chemistry, all right, the way that we like to group what we are learning is through this term here, a homologous series, okay? So we've already established that in organic chemistry, we're going through carbon-containing compounds. In particular, we're going to be going through certain groups of carbon-containing compounds, okay? And each group is essentially what we call a homologous series, okay? So it's just a group of compounds with the same functional group. So the first thing I'm going to do is write up a mini list of different homologous series or carbon-containing groups that you will likely be covering in organic chemistry. Oh, can't spell alcohols, my goodness. Okay, so we'll be covering at some point alkanes, all right, alkenes, alcohols, and carboxylic acids, all right? So we'll just use these as our 4 main groups, for instance. Right, so these 4 main groups all involve carbon-containing compounds, all right? And these are our 4 main ones that we're essentially going to be studying, plus a few others, but these are our focus. Now, with each group, okay, we can also call each group a homologous series, right? Because each group contain compounds with the same functional group, all right? AKA, these individual groups contain a group of atoms that mean that they have similar chemical properties, all right? So if we first start off with alkanes, so this is just a brief whistle-stop tour, just so you can order in your mind what exactly we're talking about. Alkanes, we already know will have a carbon in them because we know all of these are carbon-containing compounds, all right? So I'm just going to use that with C, all right? So with alkanes, they actually have a certain formula that each compound follows. So alkanes are essentially a group of hydrocarbons. And what are hydrocarbons? All they contain is what they say on the tin. Hydrogen, carbon, okay? So alkanes are in particular a group of compounds that contain hydrogen and carbon. In particular, a special feature of alkanes is that hydrogen and carbon, they are bonded together with a single bond. All right, so I'm going to draw an example and something that you guys have probably already heard of before. So we'll have our example here of methane. So you've probably come across this kind of compound before when we're talking about combustion, right? Because remember, combustion needs, what does it need? It needs fuel, all right? And oftentimes it uses hydrocarbons as fuel, okay? Hydrocarbons just containing carbon and hydrogen atoms. So, for instance, this is our structure of methane here. As we can see, it has 1 carbon in the center and it is surrounded by 4 hydrogens, okay? So it's bonded to 4 other hydrogens. And we know that because the chemical formula of methane is CH4. CH4, okay? So guys, at this point, we're just talking about alkanes at the moment. Methane is a nice example. Right, so we've established that alkanes are a group of compounds, a homologous series, okay, and they have the same functional group, aka they are made of hydrocarbons. A special feature of that is that the hydrocarbons are joined together by a single bond. What does that mean? That means that whenever you draw an alkane, you are drawing essentially a single line to join together a carbon and a hydrogen, all right? So each of these individual single lines are a single bond. So with alkanes, they are made of hydrogen and carbon, and they are joined together with a single bond, as we've seen drawn here. So that's alkanes done. Now, we're going to go on to alkenes. The reason why I emphasize that alkanes are joined together with single bonds is because alkenes are slightly different, okay? So I'm just going to erase our methane example here. Right. So what I'm next going to focus on is our alkenes. Now, interestingly, like alkanes, alkenes are also hydrocarbons, all right? So they are also made of hydrogen and carbon, right? But they have a slight difference, okay? So we're going to draw an example of an alkene, all right? I'm going to draw this right by here. So we're going to use an alkene that we call ethene, all right? Now, one way you can tell it's an alkene is because it has the same kind of ending. So alkenes are going to be ending with this ene at the end. So you'll have propene, butene, all of these kinds of things. In comparison with alkanes, we had methane, ethane, butane, okay? So they'll all have similar endings, and that's how you know it's part of that individual group, all right? So we are focusing on alkenes, and we have our example, ethene, all right? Now, we've established that alkenes are hydrocarbons. They contain carbon and hydrogen, all right? But the slight difference between our alkene here and our alkane is that when they have two carbons joined together, they will use a double bond. Sorry, they'll use a double bond. And this is how we draw a double bond. Okay, so it looks like an equal sign. And alkenes are unique because they have that double bond. All right, so what we'll also find is that this is how we draw our ethene structure, okay? Because as a rule of thumb, in organic chemistry, carbon can make up to 4 bonds, okay? We saw that with methane, how it was bonded to 4 other hydrogens, right? And now we see this with ethene in the way that I've drawn this out here. So in this double bond, okay, so we essentially have 2 bonds going on here, hence the double bond. And so this means that a single carbon can only bond with 2 more hydrogens, okay, which is why our ethene looks like this, okay? So remember, if there's anything that you take away from how to draw any kind of thing in organic chemistry, is that carbon makes up to 4 bonds. Okay, I'm just going to keep that in the corner there. So that is really important, because if you're drawing a carbon that all of a sudden has 6 bonds coming off of it, just 6 lines coming off of it, the examiner is going to be looking at your drawing and being like, what is going on here? Okay, so remember, carbon makes up to 4 bonds. All right, and so when you're drawing your double bond for ethene, an alkene or whatever, it counts as those 2 bonds. All right, so double bond. So what you can see here, is that we have alkanes and alkenes. Alkanes and alkenes are both hydrocarbons containing hydrogen and carbon, but alkanes have a single bond, okay, and that's denoted by a single line to another carbon, whilst alkenes are joined by double bonds, okay, as we see here. That looks like an equals sign. All right, so that is essentially our idea of what we call a homologous series. And I've given you 2 examples there of alkanes and alkenes. So a homologous series being a group of compounds with the same functional group. Alkanes are hydrocarbons, they have single bonds, but alkenes are different. Even though they have hydrocarbons, they have double bonds. Okay, now with alcohols and carboxylic acids, which is what we're going to be going through in particular today, these are much easier to identify, in my opinion, because even though organic chemistry is literally a whole load of carbon with a whole load of hydrogen, our alcohols and carboxylic acids have a special group of atoms attached to the end of it to let us know that it is an alcohol or a carboxylic acid. Okay, so what I'm going to do, I'm just going to rub off this section here. I'll keep up the carbon in the corner, and we're going to get our definition for a functional group so that you guys have that in your minds. Okay, so let me just erase all of this. All right, so let's flush up our definition of a functional group. Okay, so this is the definition that we're talking about when we're talking about this term here. Okay, so a functional group is essentially an atom or a group of atoms that determine the chemical properties. Okay, and in particular for alcohols and carboxylic acids, they have their own special functional groups. And in your exams, they will often have questions where they ask you, what is the functional group of this molecule here? What is the functional group of that molecule here? All right, so that is what we're going to be going into. All right, so we'll first start off with alcohols. So alcohols are a group of organic compounds, essentially carbon-containing compounds, right? And they're highly flammable and soluble in water. So when we're thinking about alcohols in terms of their properties, one thing that is really helpful is to think about places where you'll encounter alcohol in your life, all right? So it's not necessarily just drinking alcohol. Alcohol can be used in so many different parts of life, all right? Because they're highly flammable and soluble in water, we can use them as fuels, which might be something that you guys hadn't thought of, but we also use them in medicines and cosmetics. So say, for instance, all of your hand gel that we've been rubbing and using all of this time in COVID, it is made from some form of alcohol because it's a pretty good disinfectant, okay? So these are the properties of alcohols, essentially. They're flammable, they're soluble in water, which means that they're useful for fuels and useful for medicines and cosmetics. So I have a question for you guys, because this question will actually help you when you're thinking about drawing out different compounds in organic chemistry. So if a compound contains a chain of 3 carbons bonded together, what will the name start with? Will it start with meth, eth, prop, or bute? Don't worry, guys, this isn't a quiz question, so I really want you guys to attempt this question, and I prefer that you attempt it and get it wrong rather than not attempt it at all, okay? Because we need to make sure that we are all following at this point. So if a compound contains a chain of 3 carbons bonded together, what will the name start with? Meth, eth, prop, bute. To even help you answer this question, maybe think of an example of a molecule that starts with any of these. Think about what they are in your head. Draw them out, and you'll find a pattern. Which is why I said get a pen and paper, folks. We're going to be doing a lot of drawing, as is organic chemistry. I'll give you 30 more seconds. Okay, 15 more seconds, guys. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's see what you guys have said. Lovely. Yes, so 61% of you got that correct. Yes, it is prop. Okay, so one of the cool things, okay, we'll stop here. So one of the cool things about organic chemistry in general is that it is a lot of patterns, okay? So we saw that when I was first explaining alkanes and alkenes, right? The whole idea is that when a molecule is in a particular group, so if you have a molecule that's an alkane, or if you have a molecule that's an alkene, they follow a similar structure, okay, which is why they're grouped together. Same thing for alcohols, okay? In particular, alcohols contain a functional group of OH, okay? Any kind of alcohol, to know it's an alcohol, will have an OH molecule attached to it, all right? So before we start drawing out what this might be, this is an important thing to remember in organic chemistry. When you are drawing out groups of carbon, okay, when you're drawing out carbon bonds, the number of carbons that you draw will determine how it is named, as you guys saw in our previous question. Right, so we first have this word, meth. Meth corresponds to 1 carbon. Number 2, eth. This corresponds to 2 carbons. Number 3, prop, corresponds to 3 carbons. And bute corresponds to 4 carbons. Now, this kind of naming is really important for you guys to remember, because this isn't limited to just alcohols. Think about all of the molecules you've run into that contain carbon, right? If we think of methane, for instance, we know, we can tell a lot from methane's name, okay? We know first that since it's called methane, it will have 1 carbon. Why? Because it starts off with the me. Me is I am 1 person, therefore I will have 1 carbon. And we know that methane has 1 carbon. Same thing with methanol, it will have 1 carbon. Now, the fact that methane ends with that ane at the end, we saw on our first slide that the ane corresponds with alkane, okay? Because it's a hydrocarbon and it's bonded with single bonds, so it is part of the alkane group. So literally from methane's name alone, we have learned so much. One, that it has one carbon, and two, that it is part of the alkane group. Same thing that we see here. Alcohols, all right? First off, we can tell how many carbons are involved in an alcohol by what they start with. Methanol starts with the me, so one carbon, ethanol, two carbons, etc. Alcohols also end with this anol part at the end, okay? Methanol, ethanol, propanol, and what do you find that it rhymes with? Alcohol, okay? So you can identify that these molecules are alcohols because it ends with that because it ends with that ANOL ending, okay? And it rhymes with alcohol, methanol, alcohol. Same thing that we saw with alkanes, methane, alkane, butane, alkane. Same thing we saw with alkenes, ethene, alkene, butene, alkene. See, organic chemistry is all about patterns and interestingly, all about rhyming as well. Okay, so we can use this information here to help us draw out our alcohols. Okay, so this is exactly what we're going to do, and this is actually what you're expected to do in your exam. So we know that alcohols will contain the functional group OH. And typically, when you are drawing an alcohol, the OH will be attached to a carbon, okay? So remember what I said on our previous slide, carbons make up to 4 bonds. So we're going to try that with methanol. We know since it starts with me, okay, I am only one person, it will have 1 carbon, all right? So we also know that alcohols need to contain this OH. So we know that one of the bonds that this carbon is going to have is going to be bonded to OH, all right? Now, what exactly is going to be on the other 4? On the other 3 is going to be hydrogens, all right? Because in general, as a rule of thumb, in organic chemistry, it is going to be essentially carbon-based compounds, right? We're going to definitely have a carbon, but we're also going to have a lot of hydrogens as well. And whilst carbon can make up to 4 bonds, hydrogen only makes 1. Hydrogen can only make 1 bond, okay? Which is why you will never see, for instance, when you're drawing, you will never see our OH connected to that hydrogen, which is also connected to something else. It will never happen. Hydrogen only makes 1 bond, okay? So we know that, as we said earlier, our carbon is going to be bonded to our OH group. This group is what makes this molecule an alcohol. And since we have 1 carbon, it's going to be methanol. All right. So what we're going to do, I'm going to take you through this again for ethanol. And then I'm going to give you guys a couple of minutes to draw out what you think propanol and butanol are going to be. Okay. So we're going to take this through again with ethanol. Ethanol, if it starts with an F, we know that it's going to be 2 carbons. So let's start off with those 2 carbons there. Okay, they're going to be bonded together because they're friends. And we know that ethanol ends with this anol part, okay, which means it's an alcohol, which means it must have an OH at the end. All right, but we are not done. Why? Because carbon makes 4 bonds, okay? So if we look at this carbon here, first off, this carbon is currently only bonded to one other carbon. So it needs to be bonded to 3 other things. And what will those other things be? Y'all have guessed it. It's going to be a hydrogen, okay? Now, we're going to look at this carbon here now. This carbon has made 2 bonds, okay? It's made a bond with another carbon and has made a bond with our OH functional group, which means it needs to make 2 more bonds. And what is it going to be bonded to? You guys have guessed it. Hydrogens, okay? Now, what I'm going to do, I'm going to give you guys 5 minutes to draw out propanol and butanol to really test yourselves. I really want you guys to do this at home so that you guys definitely know how to try and do this in an exam. And I will check back with you guys at 10:45, okay? So answers at 10:45. So please try and attempt to draw propanol and butanol, okay? Okay, guys, you just have under 2 minutes left. If you're stuck, remember, dissect the name, okay? Look at what the name starts with, look at what it ends with, and it will tell you a whole load of information on how to draw this molecule, okay? One more minute, guys, and I'll go through the answers. Okay, 15 more seconds, guys. Now let's get this pen up. 5, 4, 3, 2, 1. 0. Okay, let's go through our answers now. So we're going to move through this a bit faster. Prop, we know, as you guys rightly said in our question, that that's going to be 3 carbons bonded together. And since it ends with anol, we know we needed to add an OH at the end of it. Now what do we have to do? Fill in the blank spaces. Remember, carbon makes 4 bonds, okay? So let's draw those in. And what else will they be bonded to? Hydrogens. So hopefully you should have ended up with this, okay? And then finally, let's draw some butanol. But is 4, so we need to do 4 carbons, 2, 3, 4, and we know that this is an alcohol, so it'll have an OH at the end. And then what do? We fill in the gaps. Why? Because carbon has to make up to 4 bonds. And we'll fill in those gaps with our lovely hydrogen. And as you can see, the longer the molecule, the more repetitive the hydrogen adding becomes. But overall, you guys have done it. You guys have smashed it. Well done. This is how we draw our first 4 members of our homologous series of alcohols. And remember what homologous series means? It's just a group of compounds with the same functional group, aka all alcohols will have that OH functional group. And as we see, these are the molecules that we have drawn. Well done. And these are its chemical formula. Okay, so well done for you guys to do that. Now we're going to move on to how does an alcohol react with other substances. Okay, so these are a set of reactions that we'll need to know for our exams, especially how it would react with sodium. Okay, so if you put a ball of sodium into an alcohol, this is going to make a salt and a hydrogen. Okay. In particular, this is the chemical formula that it will form. All right. So interestingly, the way that we name these salts would be slightly different. It's not used to what you would normally use. When you react a metal with an acid, you would say sodium, the name of the metal, plus the name of the salt that the acid makes. This follows the same similar structure, but the second names of the salts that it makes are slightly different. Okay, so we still have, with the salt here, okay, we still have the name of the metal going first. Okay, so the sodium, but in our second part of our salt name, this will be taken from our alcohol. Okay, so this alcohol is called ethanol, and it makes a salt called ethoxide. All right, same thing with if you had another alcohol, say for instance, let's say propanol. Okay, propanol we know has 3 carbons. So if it was sodium plus propanol, that would be sodium propoxide. Okay, bit of a mouthful, but mainly when you revise, you'll often see this example given here. Sodium plus ethanol makes sodium ethoxide. So it is worth knowing the name of that. And of course, we get our hydrogen at the end. Okay, now something that's also worth knowing is what sodium ethoxide, what its chemical formula is. Okay, so interestingly, what happens is that in our alcohol, the H from our OH group is essentially replaced with our metal. Okay, so it just does ye old switcheroo. And eventually what will happen is that the hydrogen from our alcohol is then removed and becomes hydrogen gas, which we know and love. And as you guys can probably see from this equation, it's actually not balanced, okay? So what we're going to do a quick little bit of balancing here, okay? Because we need to take every opportunity to balance as it comes. So I'm going to split it down the middle. All right. And I'm going to count on each side. So we have sodium, we have carbon, we have hydrogen, and we have oxygen, okay? Which means that we'll have the same on the other side. Sodium, carbon, hydrogen, oxygen. Now we're going to count what we have on each side. Left-hand side, we have 1 sodium. We also have 2 carbons. We have, remember, we have 5 here, but we also have this here. So we have 6 hydrogens, and then we have 1 oxygen. I'm going to count here. We have 1 sodium, 2 carbons. Ooh, we're counting this, and we're counting this. So we have 7 hydrogens. Oh my. And we also have 1 carbon. So really, what we're going to do as we look at both sides and see what numbers we have on both sides, the only difference really is our number of hydrogens. Okay, so what are we going to do to change this? All right, this is where it gets a tiny bit sticky. Okay, now what we can do is, because there is no other way to add on a hydrogen separately onto our left-hand side, what we're going to do is we're going to disturb the fold a bit. Now, you guys aren't going to like me doing this because it's going to involve a lot of recounting. But what we're actually going to do is put a big 2 in front of our ethanol, okay? Like I said, it's going to involve a bit of recounting, but don't get too bogged down by this. Thankfully, this kind of equation you will unlikely need to balance in your exams, so don't get too bogged down by this. But I thought it'd be nice for you guys to roughly see how this shopping list method works so that you guys can use it, even though this is a slightly harder equation, okay? So we've added a big 2. So what I'm going to do is I'm going to recount. All right, so this big 2 here applies to all of these components, okay? So this now means that we have 4 carbons and we have 12 hydrogens and we have 2 oxygens, all right? Now, as we can clearly see, we have also doubled the amount of carbons and hydrogens, our carbons and oxygens on our left-hand side. So we're going to do the same to our right-hand side. So this is what I mean by you guys aren't going to like me for this, because I'm basically making more work for myself, all right? So I've also put a big 2 on our right-hand side, and this is because our carbon and our oxygen have been doubled on our left-hand side. So we're going to do the noble thing and recount, because we've now added a big 2, and this applies to every part of this equation. So we now have so we now have our 4, and then we have to count our hydrogens. Now remember, in this equation, there are only 5 hydrogens. So we're going to multiply our big 2 by 5, which gives us 10. But remember, we also have this 2 here. So actually, this brings us up to 12. Okay, so now we've equaled out our hydrogens. And remember, this 2 applies to our oxygen, so we have 2. But this 2 also applies to our sodium. So we have 2 sodiums. And so what we're going to finally do is make sure that the number of sodiums we have on the left-hand side equal our right-hand side. So we're also going to add a big 2 behind our sodium, okay? Because now we're going to multiply that by 2, and now we have recounted, and we now have 2 sodiums on our left-hand side as well. So this is essentially what you would find if you used our shopping list method to count out both sides and multiply them by 2. Okay, this would be our fully balanced equation. So I'm going to get rid of this in 3, 2, 1. And this is our fully balanced equation that you'll see. But in general, the majority of the things that I want you to take from this slide is alcohol plus sodium makes salt and hydrogen.